Good day, viewers. Today we want to continue on further examples on variation of parameters. The example 2 that we have on the board is an example under linear non-homogeneous equation. Why is it non-homogeneous? Because the right hand side is not equal to 0. So this will require two solutions. So the solution y will be y of c plus y of b. This is the complementary solution, and this is particular integral. And I said if you want to find particular integral, you must have gotten the value of the complementary solution. In order to get the particular integral, we can either apply variation of parameter or method of comparing coefficients, which we have done in the past video. So today we want to apply variation of parameter to be able to solve the particular solution in this problem. So we start with the complementary solution. So the characteristics equation here from this question will be m squared minus m minus 2 equal to 0. Okay, this will be m squared. This will be m squared minus 2m plus m minus 2 equal to 0. So here will be m into brackets m minus 2, then plus 1 into brackets m minus 2 equal to 0. So we have m minus 1, m plus 1 into brackets m minus 2 equals to 0. So m plus 1 equals 0 or m minus 2 equals 0. So m is equal to minus 1 or m is equal to 2. So the complementary solution will now be given as c1 exponential minus x plus c2 exponential 2x. So we have gotten the value of the complementary solution. So here this will represent y1 and here will represent y2. So how do we get the value of the particular the second solution, particular solution? Of course, the particular solution by formula will be given as v1 exponential, that will be v1 y1 plus v2 y2. In this case now we have it to be v1 y1 is exponential minus x plus v2 exponential 2x. So for us to be able to get the particular solution, there is need for us to find the value of v1 and value of v2. How do we find the value of v1 and v2? So we know, just say since we know that y1 is equal to e exponential y2 is equal to exponential 2x, then phi of x, the right hand side of that equation, is equal to what? Exponential 3x. We know this. Since we know this, then it follows that we are going to rewrite this as a system of linear equation, that v1 prime exponential ex, okay, plus v2 prime exponential 2x is equal to 0. Then since we have is over that 2, the next one will be equal to the right hand side. Then we are going to have this. When we differentiate this second one, then we are going to write what we have there. That is how to be able to do that. That's what we do there. Okay, that is what we are going to do there. So this is v1 prime into bracket exponential. So we have this to be exponential. When we differentiate this, what we have here, when we differentiate what we have here, we are going to have to be minus e minus x plus v2 prime into bracket. When we differentiate what we have here, 2e 2x is equal to exponential 3x. Equation 1, equation 2. So there are two equations. So how do we get the value of v1 prime and v2 prime before we integrate and get the value of v1 and v2? We are going to solve that simultaneously. So we are going to solve what we have there simultaneously. So we are going to solve the two equations simultaneously. Okay, that's what we are going to do. So if you look at it very well, if I had equation 1 and 2, if I had equation 1 and 2, this will cancel out because this is positive, this is negative. This will cancel out. Just say add equation 1 and 2. Then this is 2. This is only 1. We are going to have three V together. That's what we are going to have. Then from there, we are going to have V2 prime to be equal to, of course, this can be 1 over 3 when we divide both sides. Then exponential 3x exponential, when we divide both sides by exponential, that will be minus 2x. Finally, V2 prime will be equal to 1 over 3 exponential x. That's what we are going to get. That's what we are going to get as V2 prime. So since we have got the value of V2 prime, we just say substitute V2 prime, which is equal to 1 over 3 exponential x into, we can substitute this into equation 1. What is equation 1? V1 prime exponential minus x, then plus, instead of V2 prime that we have here now, I will change it to 1 over 3. 1 over 3 exponential x multiplied by exponential x. That's what we are going to have. Is equal to 0. So if you do that, correctly, then there will be some cancellation. Okay, so that we are going to get the value. This will cancel this. So we are going to get the value of our V1 prime exponential minus x to be equal to minus 1 over 3 exponential 2x. When we do V1 prime will now be equal to, by the time we divide both sides by exponential minus x, at the end of the day, if we divide both sides by exponential minus x, here is, no, what we have here is 2x, not x. This is 2x. So here is 2x, not x, 2x. So 2x, this times this will be 3x. So we have 3x here. Then at the end of the day, we have minus 1 over 3 exponential. By the time we divide both sides, that will be 4x. So this is for V1 prime. Then this is for V2 prime. So we are looking for the value of V1 and V2. So what do we do here? We just integrate. We are going to integrate V1 and V2. Once we integrate this, we get the value of V1. Once we integrate the second one, we get the value of V2. So by the time I integrate this, if I integrate this, I'm going to get this V1 to be equal to maybe 1 over 3 integral exponential 4x. That's what I'm going to get there. So if I integrate this now, I'm going to get this to be minus 1 over 3 multiplied by, if I integrate this, I'll get it to be 1 over 4 exponential 4x. That's what I'm going to get. Okay. Then at the end of the day, I'm going to get this to be minus 1 over 12 exponential 4x. This will be the value of V1. Then let me go ahead and find the value of V2. So the value of V2 here will be, if I integrate this, if I integrate V2 prime, I'm going to get V2 will be equal to 1 over 3 integral exponential x. So if I integrate this, I'll get 1 over, that will be 1 over 3 exponential x. That will be the value of V2. So finally, the particular solution, which is given as V1 y1 plus V2 y2. So what is V1? V1 is given as minus 1 over 12 exponential 4x multiplied by, what is y1? We know y1 to be equal to e minus x plus V2, which is given as 1 over 3 exponential x multiplied by y2 e2x. So let's open up here. This will be minus 1 over 3 and minus 1 over, this is minus 1 over 3 exponential 3x plus 1 over 3 exponential 3x. That's what we are going to get. Okay, that is what we are going to get. Here is 12. No. V1 is 12. V1 is 12, not 3. Here is 12. It's 12. It's 12, not 3. So if you add these two together, when you find the LCM, that will be 3. It will be 12 minus 1 plus 4. That will be 3 over 4. That will be 3 over 12. So this is the same thing as 3 over 12. That's what we are going to get. 3 over 12 exponential 3x, which is the same thing as 1 over 4 exponential 3x. That's what we are going to get. So the value of the particular integral, the particular solution yp is given as this. Finally, finally, this general solution, which is same thing as yc plus yp, will now be equal to what is yc? C1 exponential minus x plus C2 exponential 2x plus the particular solution, which is given as 1 all over 4 exponential 3x. This will be the final solution to the non-homogeneous equation. That will be the final solution to the non-homogeneous equation too. So please, let's take notes. Let's take notes. That will be the final solution to the non-homogeneous equation. So let's take notes. And if you compare this with the past video where we use method of comparing coefficients, you realize that we arrive at the same answer. So let's take notes. Let's take notes. So that is that about that. So, and there's this other question also, that we have used that formula, we have used the first method, comparing coefficient, to solve. So I want us to attempt this. So no, I will do it to a particular level. Example 3. So I'm going to start it, but I will ask you to complete this. Minus 5 dy dx, then plus 6y is equal to 2 sine 4x. If you check the video on further example on undetermined coefficient, we have used that method of undetermined coefficient to solve this. So we now want to go ahead and solve this using variation of parameters. Of course, the first thing that we are going to do is for us to be able to find the complementary solution, because the general solution to this problem would be y, which is same thing as yc plus yp. So if you want to find the complementary solution, we are going to write out the characteristics equation, which is given as m squared minus 5m plus 6 is equal to 0. We equate the right hand side to be equal to 0 in order to be able to find the first solution. So if we do that, what are we going to get here? We are going to have m squared to be equal to minus 3m minus 2m plus 6 equal to 0. Of course. So m will be equal to m into bracket m minus 3 minus 2 into bracket m minus 3 equal to 0. So m minus 2 into bracket m minus 3 equal to 0. So m minus 2 equals 0, or m minus 3 equals 0. So m is equal to 2 or 3. That's value of m. So the complementary solution y will now be equal to c1 exponential 2x plus c2 exponential 3x. That's what the complementary solution will give us. Okay? So once we know the complementary solution, we can go ahead and find the particular integral. The particular integral. That is, we say that the particular integral by formula will be v1 y1 plus v2 y2. That's what the particular integral will give us. So what is the value of v1 and the rest? Of course, y1 will be this first one, then y2 will be the second one. So in this case now, what we are trying to say is that yp is equal to v1 exponential 2x plus v2 exponential 3x. So we go ahead and find the value of y1, v1 and v2. How do we do that? We resolve this into a system of linear equation. That is, what we are going to do is that we say v1 prime into brackets e raised to power 2x plus v2 prime into brackets e raised to power 3x is equal to 0. Then this next one will be v1 prime. We differentiate what we have here. 2e2x plus v2 prime 3e3x is equal to the right hand side here, 2 sine 4x. This is equation 1. This is equation 2. So once we have the two equations, we are going to solve these two equations simultaneously in order to find the value of v1 prime and v2 prime. So if you find the value of v1 prime and v2 prime, just go ahead and integrate v1 prime in order to get v1. Then you go ahead and integrate v2 prime in order to get v2 prime. At the end of the day, we must get the same value. And of course, from what we have here, I will resolve. I'm going to solve this. So what do we do here? I can multiply equation 2 and equation 1 by 2. If I multiply equation 1 by 2, I will say 2 multiplied by equation 1. If I do that, I'm going to get v1 prime 2e 2x plus v2 prime 2e 3x is equal to 0. I can call it equation 3. Then what do? I will say equation 2. I will say equation 2 minus equation 3. If I say equation 2 minus equation 3, I want to get the value of v1 prime. If I say equation 2 minus equation 3, what will be the solution? Equation 2 minus equation 3. This will cancel out. This minus this, I'm going to get v2 prime exponential 3x to be equal to 2 sine 4x. That's what I'm going to get. Okay? That is what I'm going to get. At the end of the day, v2 prime will now be equal to 2. That will v2 prime will now be equal to 2 if I divide both sides by exponential 3x. So that will be exponential minus 3x sine 4x. Okay, this value of v2 prime. Then how do we get the value of v2? No, that's what we need. We need the value of v2 and v1. We go ahead and integrate this. Once we integrate, of course, this is combination of two different functions, exponential function and trigonometric function. So we are going to apply integration by parts on this to be able to integrate this. So since we know this, then we can go ahead and substitute. We just say we are going to the value of v2 prime. So we can just say from equation 1. We say from equation 1, v1 prime exponential 2x can be equal to minus v2 prime exponential 3x. Okay, and we know the value of v2 prime. So we say v1 prime exponential 2x to be equal to that will be v2 prime will be minus 2 exponential minus 3x sine 4x exponential 3x. That's what we're going to get. Then this guy should be able to take care of this. At the end of the day, we have this to be minus 2 sine 4x. Finally, v1 prime will now be equal to minus 2 exponential minus 2x sine 4x. That's what we're going to get as the value of our v1 prime. So for us to be able to get the particular integral now, we must integrate this v1 prime to be able to get the value of v1 prime, then v2 prime to be able to get the value of v2 prime. So we are going to apply integration by parts on this. So if we apply integration by parts on v1 prime and v2 prime, we will be able to find the value of v1 and v2. So I want us to just complete this. Go ahead and use integration by parts to solve the value of v1 prime and v2 prime. So if you integrate this correctly, if you integrate v1 prime correctly, you are going to get what I'm about to write on the board. If you integrate it correctly, this is what you are going to get. You are going to get 5x. We are going to get 2/5. You get 2/5 exponential minus 2x cos 4x plus exponential minus 2x sine 5x/5. Okay. If you integrate v2 prime correctly, we are going to get what I'm about to write. We are going to, if you integrate that correctly, v2 prime correctly, we are going to get minus 8/25 exponential minus 3x cos 4x minus 6/25 exponential minus 3x sine 4x. This is what we are going to get. Apply integration by part on this. Apply integration by part on this second one. So if you do that correctly, you are going to get the value of v1 prime and v prime you get the value of v1 and v2 as we have it on the board. So if that is the case, then just go ahead and substitute the value. So please, I want us to check it out using integration by parts. When you have combination of two different functions, then of course it is expected that we use integration by parts. So that finally y, the final solution to this problem, now y is equal to yc plus yp. Then what is yc? Of course, we know yc. We know the value of the complementary factor. Let's first find the value of yp, the particular solution. Yp is equal to v1 y1 plus v2 y2. So we put in the value of v1 minus 2/5 exponential minus 2x cos 4x plus exponential minus 2x sine 4x all over 5. This is 4. Here will be 4x. Okay? That's value of v1 into bracket. What is y1? What is y1? Y1 is the same thing as exponential 2. That will be exponential 2x. Then plus, what is value of v2? Minus 8 all over 25 exponential minus 3x cos 4x minus 6 over 25 exponential minus 3x sine 4x. Then y2 is exponential 3x. That's what we are going to get. If we do that correctly, then we can actually expand. When we expand, what are we going to get? We can expand. When we expand, what are we going to get? There will be some cancellation. This is bracket. Okay? E2, we take care of this. This E2x, we take care of this. At the end of the day, what we are going to have here is minus 2 cos 4x over 5. Then plus sine 4x over 5. Then in this case also, E3x, we take care of this and we take care of this. At the end of the day, we are going to have minus 8 cos 4x over 25. Okay? Then minus 6 sine 4x over 25. That's what we are going to get. That is what we are going to get. So if you now combine the two, what are we going to get? By the time we combine it, when we combine the two, what are we going to get when we combine the two? That's what I'm about to write now. V1. This one is equal to, not minus. Here is equal to. So this place, there's no minus there. So if you combine the two, what are we going to get? If you combine the two, we just have it. Just like when we take LCM. The LCM of everything will be 25. Okay? The LCM of everything will be 25. So 5 in 25, that is 5. 5 times 2. We are going to have 10 cos 4x plus 5 sine 4x minus 8 cos 4x, then minus 6 sine 4x. So when we look at this very well, 10 minus 8, that will be 2 cos 4x. Then 5 minus this, that will be minus sine 4x, everything all over 25. That will be the value of the particular, solution. Then finally, the final solution to this problem, this yp. So the final solution to this problem is yc plus yp. And that will be the complementary solution, which is c1 exponential 2x plus c2 exponential 3x. Then plus, but this is value for particular integral. We can split it as 2 over 25 cos 4x minus 1 over 25 sine 4x. So if you compare this result with the result when we apply method of undetermined coefficient, you realize that we arrive at the same answer. So it is very simple and straightforward. But please note that we only found the value of v1 and v2, the value of v1 prime and v2 prime. So you are required to integrate v1 prime and v2 prime using integration by path to be able to get the value that we have here. I didn't show it. I only write out the result. So please try and do that to verify that what we have done is correct. Thank you.